Hello, everyone, and welcome to Schaumburg, Illinois, here at the Sandvik Coromant Center. Uh, Thanks for joining the webinar. Today, we're going to dive into taking a look at reducing our roughing turning cycle times by 30%. We're going to talk about technologies on how to do this, and we're going to talk about not only tooling technologies, but we're going to talk about programming and software.
Okay.
So, let me introduce myself first. My name is Keith Brake, and I am a turning product manager for Sandvik Coromant, representing Sales Area Americas. And today I'm joined by Mr. Andy Hefner from GibbsCAM. Andy, could you intro yourself a bit for us, please?
Thank you, Keith. Thank you very much. Yes, my name is Andy Hefner. I am the Senior Applications Engineer with GibbsCAM. About myself a little bit, about 30 some years ago, I came with a German machine tool company from Germany over to the United States and started working here. I'm living here still since. About 22 years ago, I joined GibbsCAM as an applications engineer, and I'm still with GibbsCAM today. And this is pretty much about my self and stuff. Okay, and let's get into.
Thank you for the intro, Andy. As it is always with Sandvik Coromant, it's safety first. So we want to make sure that all of our audience and all our participants in the webinar are in a safe place and understand how to keep yourself safe. So please know where your emergency exits are, understand where your assembly points will be, and also any emergency numbers that you may need to use for any emergencies that could come up. Psychological safety, what we mean by this is feel free to ask all the questions that you wish. We will have a Q&A session at the end of all of the presentations. So make sure if you have questions that you want to ask, get those into the chat. And then if you're in a place where you need some protective equipment, make sure you have the proper PPE. Also know where your first aid kits are, Andy, and then what the alarms sound like in your area so you know how to properly react. And then last but not least, we want to touch upon the health and well-being of the audience and everyone concerned with the webinar. And what we mean by this is if you find yourself in an uncomfortable place, if you need to get up and stretch, if you need to simply exit the webinar, feel free to do anything you need to do to keep yourself healthy and in a well place where you're feeling comfortable. So, Andy, with that said, we're going to move into a little bit of what we came here to talk about today.
Okay.
Roughing cycles. That is in large part, when we start talking about turning applications, roughing cycles is where we can make or break a large percentage of our throughput. Okay, if we are taking advantage of technologies such as chip thinning technologies, if we're taking advantages of things such as programming technology and new methodology that's going to help us increase cubic inches, have a secure system, get more parts out the door, that's really the name of the game. Because after all, our clients, our customers, and even ourselves, the name of the game is getting parts out the door and making money, right?
Absolutely.
So people want to understand how can we use technology to make money? And that's kind of what we're going to talk about here today. I'm not necessarily going to mention anything super new from the Sandvik Coromant side of things. We do have very exciting new technology that released last fall, so we're definitely going to touch upon that. We're going to have a really great demo later. That's going to come straight out of GibbsCAM and then run into the machine. But we'll start with tooling technology. So, Andy, I'm going to just kind of dive in here. And
Please, go ahead.
Yeah, no secret what's on the screen. I mean, a round insert has been a productive way to rough turn for years and years. And chip thinning technology is really nothing new. But there's always been holdbacks and drawbacks to using the round insert. First of all, we cannot create a square shoulder with a round insert. And no matter what we do, we're never going to overcome that. But we did have some other drawbacks that come from the market that Coromant has listened to and we've addressed. And I think we've addressed them in a very good way. So if we take a look here at our CoreTurn 107, our round insert with a rail, you can see we have shim protection. We have the shim screwed in separately. And then here you see some insert selection with our chip breakers. We have 4 different chip breakers. But here's where the magic comes in with this system. We have those serrations on the bottom that sit on top of our eye-lock rail. Now, no matter the rotation of the insert, we get locking on the pads and we do not have any insert rotation. So traditionally, Andy, people would think if I'm dynamic roughing or if I'm tricorder roughing or if I'm using VoluTurn out of GibbsCAM, eventually this breaks down. And so this must not be a robust way to machine. But the reality of the situation is it's a very robust method. It's a very productive method. But what happened would be the micro movements within the insert. Yep. And those micro movements start to stretch the screw. And when the screw stretches, of course, we have a failure. Okay, so, and it's really difficult sometimes for the market or the end user to really identify where that failure's at. And that's where this iLock rail comes into play. It eliminates those kinds of failures. The other thing that the iLock rail does, it allows us to have indexability. Okay, big piece of feedback from the market, and I've heard it as many times as I care to mention. We don't like round inserts because we don't always get the use of all of our carbide. We don't know how far to index them. That's the beautiful thing about the CoreTurn 107. Okay, indexes on the bottom, the slices, they match up, built-in indexability, built-in security, and no worries when it comes to a robust process if properly programmed. And we can realize cubic inches removed with this method if we don't need square corners, seriously elevated above traditional ISO turning. Second piece of Sandvik Coromant technology that I want to speak to is prime turning.
Yes.
Now, Andy, we're going to use some prime turning today. We're going to use prime turning, our second generation of prime B, okay, new style insert. And we're going to talk about that. But we want to make sure that the audience understands, you know, prime turning, we've seen cycle time reductions in with a proper application as high as 50% when it comes to roughing. These are not made up numbers. These are real numbers. They're achievable numbers if things get dialed in appropriately, if things are properly identified, and everything comes into play. But prime turning itself is not new. Okay, we've had a generation 1. But we had some things with generation 1 that we listened again to the market and we knew we needed to address. So we want to take a look at the improvements that we've made with generation 2 because it's such a much more robust system that you really cannot compare the two, generation 1 to generation 2. But before I go there, Andy, do you know the technical definition of prime turning? What the prime turning actually means?
Okay, let me try to dig in what I know about it, or the little bit that I know about it. It's called the true, or I think it's a true or real bidirectional turning, if that's somehow describes it.
Yeah, the market and the perception on the market, and it describes it very well, actually. But the perception on the market is prime turning is just we engage that high feed side, and that's all we can do with the insert. So if your application doesn't call for that or can't handle it, the insert is useless. And that's really not true. Okay, that's just high feed turning or chip thinning turning. That's simply taking advantage of physics, Andy. That's all we're doing. Okay, we take advantage of those physics to be able to feed harder. The chip is thinner, so we can spin faster. All these things add up to this 30, 40, 50% sometimes cycle reduction. And the interesting thing is we also get better tool life, right? Or we can if we're properly dialed in. But all directional turning is truly what prime turning means. So as we take a look at this demo, we see some of that all directional turning. Okay, so now the improvements generation 1 to generation 2, very substantial improvements, Andy. We have a thicker insert. We have a double-sided insert. Okay, generation 1 was single-sided. Now within this pocket, we are shim protected. We have 7 contact points on this insert, 3 on the face, 4 on the walls. Okay, we've also doubled the amount of undercoolant that we have in our coolant delivery. Back up, I'm going to run this animation one more time. Take a look at another benefit of generation 2. We've also increased the depth of cut capability for facing cuts. Now this insert is capable of 4mm depth of cut radially, 4mm depth of cut on the face, and also we can realize if we have the horsepower and we have the setup, we can realize feed rates as high as 150 thousandths per revolution.
That's amazing.
It's amazing.
Absolutely.
Yes.
Yeah.
Opti-thread. Now, this technology, this is not hardware technology, Andy.
Mhm.
It's a software that Sandvik Coromant has. And people may be thinking, why in the devil are we talking about threading when we're reducing roughing cycles by 30%? This might be a little sneaky way to keep your doors closed, okay? And really, when we talk about reducing cycles, we talk about reducing all time involved in cycles. Threading, in large part, can be considered part of a roughing cycle.
Mhm.
So, what is the most detrimental thing to an autonomous cell or a robotic cell?
Chips.
Chips.
Long, stringy chips. Yeah.
Yes. And the reason for that is because the robot can't function, right?
Correct. Yep.
So if the robot alarms or the autonomous cell can't run and we have to interject human power, right? We have to have operator interaction with a cell. We are increasing the times tremendously and actually exponentially over each part every time the green light goes off. So Sandvik Coromant has developed a software to help control these chips. Software is called Opti-thread. It can be found in our CorePlex toolpath. You can get that online. But what this Opti-thread method does, we can see here it's a series of alternating curves, Andy, and we never have the peaks and valleys aligned, okay? We are actually mechanically controlling this chip. Now, we can see here in the animation, the inserts diving in and out of the cut. Now, some people might be thinking, well, that's going to kill my tool life, or we're no way we're secure enough for that. Well, with our CoreThread 266, again, to get these cycle times down, you have to have the proper technology.
Mm-hmm.
With our CoreThread 266, we're locked in on that eye rail, that eye lock rail. Therefore, we have no movement in our insert, and it will stand up to this method. We in and out of the material. We're breaking chips. The final path is actually straight because we all know we have to have a quality thread by the time we're done,
Mm-hmm.
and this has to be a straight cut. The beauty of this method with our software, if we make an insert for this, you can cut that thread with Opti-thread.
Right. Yep.
It is that simple. Now, there's two benefits that we learned along the way that we actually didn't count on. You know what they possibly could be?
Help me.
Okay. The first one is an improved quality of thread.
Okay.
Okay. So we find we have an improved quality of thread. We're able to take less passes to get this done.
Tool life.
But with tool life,
Hey,
exactly.
yeah,
When we
yeah.
move in and out of the cut, we are moving potential for notch wear. We never taking the top of the heat zone and repeatedly placing it on that insert in the same spot the way we do with traditional threading. So we keep our doors closed.
Mhm.
We control our chips mechanically. We have a perfectly fine quality of thread. If we make an insert for it, you can cut the thread, and we found out we get better tool life. So threading might not always be considered as a way to reduce the roughing cycle time, but if you're running an automated cell and you have 30 seconds worth of cycle time per part, and you have to stop that cell for 5 minutes to unjam the robot, you have lost all your productivity.
Yep.
So certainly something that needs to be considered. Now, here's the technology that I mentioned that is very new. We released this last CoroPack last fall, and it is called CoroPlex YT. And Andy, this is Y-axis turning.
Mhm.
What have you seen, and what are your thoughts on these tools when you program them and you see them in action? What sticks out to you? Before I go into the description, what sticks out to you?
Well, definitely the rigidity of the tool and the design, actually the way it is built. It's a combination of inserts that you're actually using here, and we will see this shortly. I love that actually, like when we turn in the y-axis, the tool is pointing, the insert is pointing down. Okay, so basically all the chips that are actually being cut shoot right down there in the chip pan. Okay, and don't get wrapped around somewhere else and stuff. Okay, so there's a lot of benefits that I see in those tools, and the rigidity is amazing.
Yes. Yeah, and you've pointed out some of the really, mechanical highlights of the tool, the
Correct.
robust nature, the way that the pressure, seems to go up into the
Into the
spindle
tool. Yep.
when we cut that way. But Here's other benefits of this tool, and I do have an animation, and then, Andy, you're going to take over and you're going to show us how really easy it is to, kind of program these tools in GibbsCAM, because when I show this animation, large majority of the audience is probably going to think, who in the world is going to program that? Because it looks very daunting, but combining technologies, powerful technology, reducing roughing cycle times, that's what we're doing. And your technology compared with Coromant technology really makes this a productive and fairly efficient way to program, as efficient as any other, I would say. So when we look at the overall benefits of this tool, we have inserts on both sides, and we have indexability within the tool without returning home for a traditional full tool change cycle on a multitask machine. We're talking reducing chip-to-chip time from 18-20 seconds, depending on machine capability, down to 4 to 7 seconds. If you're running high volume, or if you want insert consolidation, or if you want extra sister tools in the chain or tooling redundancy, fantastic system to allow you to do this. Because if we look at this tool, this can be a left or a right-hand tool or a neutral tool, and we have 2 inserts on there. One tool, 6 cutting positions without going to the tool change belt. So how does this work? We'll take a look at the animation here. This is our prime A insert on our Y-axis turning platform. And when we look through this simulation here, Andy, this looks pretty simple. Oh, what happened there? We rotated the A spindle. Okay, now we're into the magic of the platform. And we can sweep these cuts coming down. Now, why would we do that? While this round insert is roughing out this pocket here, why would we sweep the insert? Well, there's several reasons why we sweep the insert. We can have a burr-free cut. We can have no blend lines around left and right-hand features. We can control the chip thickness for maximized chip control. And we can engage all of that nose radius of the piece of carbide, which sometimes we don't always do. This allows us to get the maximum value out of our piece of carbide. It allows us to have a maximum quality part, no blend lines, no burrs, seamless cut. It's more rigid. All these things add up to increased throughput. Absolutely. More rigid, you can push the tool faster, okay? And when we talk about multitask machines, the largest pushback that I get from multitask machines from the market is the long tool change time. Well, now we have a way, combined with the GibbsCAM technology, to have 6 tools in the spindle at the same time. And it might not make sense to you now, but I feel very confident that it will by the time we're done here, Andy. So because this is new technology, and sometimes it's hard to wrap your head around really what's going on here. But before I turn it over to you, anything you want to add based upon what you've seen here with the Coromant technology? I mean, you've spoken to the rigidity, you've spoken to the flexibility, all of these things. Any other thoughts before you take over with your demo?
Well, the way they are designed, those tools, is just fantastic. And like you said also earlier, that the tool pressure or the cutting pressure gets pushed up into the spindle. And that's where the tool is the most rigid ever. So there is no deflection on the tool, or very little. Most of the cutting pressure gets into the spindle, and that's where the rigid part comes from and stuff. It can hold everything. Those are most impressive tools. It's fun to work with them. It's relatively easy to program them, and that's actually where I think, hey, my God, okay, those tools, they offer so much opportunities now and flexibilities that we haven't thought before, and that's what impresses me the most of those tools. Absolutely.
Yeah, and I do agree with you that you're limited by your imagination.
Yeah,
because you have full 360-degree application. If your machine tool, of course, has the capability to do this. And we'll talk about that a little bit later. There's some complications, we'll call them. There's things that have to be in place, but if you have machines that check the boxes, you really should look at this technology to help you reduce your roughing cycle times. But with that said, we've alluded to the fact that these appear to be very complicated to program. I can tell you firsthand, when these tools first came to me, in the position I have, I get to see them a little sooner than some. Sure. My first thought was, wow, this programming is really going to be something. And then I saw the software. So I'm going to pass it to you, Andy, and let you demo the software and show folks just how really not really complicated it is to
Okay.
get code here.
Thank you very much, Keith. Okay, so and now welcome again. Let's do a little bit of GibbsCAM demonstration here. So what you see here already on the screen is actually Mori NT or NTX machine, DMG Mori NTX 4250, and this is actually the machine we're going to be cutting the part later on. Okay, first what you see here, I simulate our part real quick. Okay, I often start out with a demonstration like this. Okay, so we're going to have the part being cut, we simulate it, we see already what we are doing, and then I go to more detailed explanation how Gibbs is working with the tools, with the individual kind of operations and processes, how we apply the Gibbs process and tools to machine the part and how to program it. Okay, so we just actually did the prime turning at the beginning. Now we do the probably we slow it down a little bit. There we go. Okay. Now we machine that wider area with our round button insert. And I speed it up a little bit. We don't need to have it run slow like this. Okay, so now we do a little bit more cutting the corners, cutting here, and of course, very quickly, you see our sweeping. Of course, it was very fast, no worries. I will show it to you later, much more detail without the machine simulation in the back. Okay. Let's close machine simulation and let me go into our first operation. Or let's maybe start first with our tools. Okay. Typically, when we start with GibbsCAM, we first select our machine. In this case, like I said, it's a DMG Mori NTX 2000 with y-axis turning. We set it up, okay, our stock and things like that. Okay, so we also can give it our material that we're machining, and then we actually can use later on for feeds and speeds recommendation. So, but most importantly, okay, this is our stock definition over here. And then, of course, RV and inch or metric. Either way is fine with GibbsCAM, so whatever you prefer or whatever the part is being drawn in. Okay, this is how we select the machine first. Then you have over here on the left, we have our tool list. And of course, you see already a bunch of tools there that I had selected for other jobs. And often I leave actually similar tools already in it because I use them probably repeatedly as often as I can. But let me show you actually how easy it is to select actually a tool. So we click on an empty tool tile here, and then we get actually our milling tools, our turning tools, okay, in this case, of course, whatever shape it might be, 55-degree E-style and stuff, and of course, any milling tools. In this case, we're doing most actually all turning and not milling, but anything actually you would think of that you would really need for any part actually is available right there to you, and that is basically ready to be used to set the dimensions. Let's go back to that. The tool radius, okay, the inscribed diameter, and so on. Okay, so let me actually go back to this. So once I actually have selected a tool, let's go back to this, or define the tool, I can simply go back. Okay, so now I have selected a tool, and I'm looking actually in this case already at our prime turning insert, the B style, second generation prime turning insert that we are using with y-axis turning. And here is the combo tool, okay, that actually Keith had mentioned earlier. That's tailor-made, but on request, of course, it's available to the user. And that's what we hear right now. You can see a solid in here. So what we actually do in GibbsCAM, once we selected a tool, we then also can say, okay, so what do I want to do with this tool? I want to do some turning and just drag and drop it actually into my process tile. And now I'm going to basically tell it, okay, what do I want to do? In this particular case, it's prime turning. So I click on our prime turning icon, and now I decide, okay, this of course is a roughing insert. the prime B insert. Okay, so we select between rough and finish. Of course, like I said, roughing is the one we're gonna do. We get it our recommended depths of cut, so we have actually a min max. Okay, so we should be stay between those min max values. Okay, and of course, it's always a good start to be somewhere in the middle. Until you get familiar with the tool and see what the insert allows to cut with and stuff. A lead in radius. You probably will see this later when we run. No, we will see this later when we run actually our simulation. And then of course our feeds and speeds. A common surface footage, okay, with regular steel of 1000 surface footage. And here are some feed rates. They are aggressive. We could go bigger, but not very conservative either. So they're pretty aggressive, but there is actually still room for going faster in the feed rate per revolution. And of course, if you leave some stock over here, an X 20,000 for the C stock, okay, 4,000. And of course, how I do approach my part, okay, like clearance and the stock size. Okay, so this is pretty much okay whenever you select a tool, it also then allows you to select whatever you want to do, a roughing, you want to do a finishing, tool pass, is it milling into the turning, pretty much always the same thing. Okay, let's go back to our prime turning. So I already explained here what we're doing over here, but now how do I actually tell the system where do I want to machine? In this particular case, I have geometry. I extracted geometry from my solid that I have. You can create geometry on your own. You can create geometry and then create a solid in GibbsCAM as well. But once again, you have the geometry, I'm now going to set my machining markers. Okay, so prime turning, as we said earlier, Keith had said, okay, like we are turning backwards, we're turning away from the spindle. So I set my machining marker close to the spindle. You see the white button, and my blue arrow points in the direction where I'm going to be machining. And then I set my black marker, let's say, I set it right there. Okay, so what I just did, I set my white marker where I start, and I can actually drag the balloon out a little bit further, and I said my last element that I want to machine is this one. Actually, let me correct that. I'm gonna set it actually to that radius. Okay, so I can basically come down here. So this is my end marker. So I want to machine the part all the way across here using our prime B insert. One other thing, I don't want to dive with our prime B insert into that valley over here, okay? So I take the X plus away from it. So it says, okay, stay away from that area. Don't dive with the insert into that area down here. Okay, so if I now say do it or redo, let's make sure, yep, there we go. Say redo in this case, because I already created that operation. I click on it, and it's briefly created a tool path in the conventional kind of x-axis, but it then flips it around to our y-axis. And it knows that automatically because the tool that I'm using for that is a y-axis tool. It's designed like this, so the system knows automatically that my toolpath has to be created in the y-axis plane and not in the conventional x-axis plane. And this is actually how easy it really is to go from conventional machining within GibbsCAM to y-axis machining in GibbsCAM. Okay, so that was a little bit detailed. Let's go through the other operations a little bit faster. Again, it always pops up, okay, like when I double click on an operation that I already created. Hey, what do you want to change anything? Want to modify any feeds and speeds or anything like that? Make any corrections in here. So you can do it. If you like it, just click redo or do it. Okay. So again, I set my machining marker up here. And down here, I'm gonna face the that area again, y-axis motion. Okay. This is our VoluTurn with our round insert. Again, we do it in y-axis. What have I done? I set my, oops, that was not correct. I set my machining markers over here all the way through here, but now I want to machine this, complete this valley actually, and rough it out with our round insert in VoluTurn. Okay, machining marker set. I click on redo in this case. Redo, there we go. And here is my toolpath. And so quickly, I'm now cleaning up down the corners where actually our round insert left some stock. And as you can see here in GibbsCAM, we have an option that says material only. So no matter where I set my machining marker, see, they're actually set here, down here. It defines actually a much actually another area or longer part of the geometry. But with this material only be set, it only gives me toolpaths where it sees remaining material left over from our round insert machining those corners. So very efficient toolpaths. We're going to do the same thing over here in the little white groove down there, and we flip it around over. We are using actually now tool number 17, which actually is pointing in the other direction over to that shoulder over here, and you will see that later on is when we do the simulation. Again, cleaning up with material only being set, only gives me toolpaths where material still exists. And we do the same thing over on the front here, and one more time. Flip the tool around, another 30 degrees or something like that, and machine that area again with material only being set. And now comes the hit of the show, if I may say so. Okay, this is now what we're doing, y-axis turning, including sweeping toolpaths. Okay, so again, I just clicked on the operation. It brings up my geometry and my vectors. In this case, all those green lines that you see sticking up there out of the part, like a little porcupine. This is actually what we need for our y-axis turning when we do want to sweep with our insert going through those valleys and so on. The setting in here is, again, very similar that you have seen in the other operations that I showed you. Back here, I have now a rotate tab. And with this rotate tab, and I click on this, I have another section. It's selected vectors. And those things, those little porcupine needles sticking out of, those are vectors that I had set in GibbsCAM. So, and those vectors actually tell the tool which way to point towards the part. Okay, so this one comes straight toward the face of the part. Then we come around the corner here and we will sweep around that radius from 0 degrees to 120 degrees. Okay, so that sweeps around, then we travel along. So I set these sweeping motions going through the different angles with vectors. I selected here, so I basically those are all the vectors, 120, 120, 120, and so on, until the end of the part. Okay, I can click redo, but I don't have to. So basically, what you will see in a second or two, or maybe 5 or 10, this area being machined where the tool basically always angularly adjusts itself to machine the whole section in one sweep through the whole thing. And down here, of course, now it's with all those lines, this is the toolpath that it's going to be doing all in one shot, not pulling out away and coming back. No, it does it in one shot. Okay. With that said, are you still with me, Keith?
Yes, I'm
perfect. Okay. All right. Okay, with that said, let's show the motion. Okay, I'm going to go back into machine simulation. Okay, what I want to do, I want to hide my machine model. I basically just want to show you the machining itself. So we see the tool, we see the part and the chuck, of course, so making sure we don't have any interference with the chuck and the tool. Okay, so, all right, let's give it a start. So we're gonna see our tool rotating around to our B-type prime insert. Okay, prime B, and here we are machining. Let me rotate it a little bit more around so you can see a little bit better. There we go. Okay, it's a prime B insert. Roughing the material out, we come around the front there, and now we're gonna set up and machine the face of the part. Now we come up with our round button tool insert for our Voluturn operation. There it is. Okay. We go a little faster. Okay, roughing out that white area down there. And as you can see, there's always the round button insert. It's the nature of it, leaves material. And of course, we are cleaning that up. Oops. I wanted to slow that down a little bit, let it run. And I show you a little trick that I can do within GibbsCAM as well. Okay, so it was a little fast the way it ran through. I was sweeping because I want to focus on that. So I select that operation and I select skip unselected ops. So what the system does automatically for us is machines in the background all those previous operations, the roughing and everything that we did before. And now it only focuses on that last operation. And I let it really slow down now a bit. Maybe a little bit more like this. Okay, we sweep around that radius, we drag, and now we sweep in that bottom of that white groove. And again, we come down the shoulder and turn around, angle the insert to the other side, and we are done. This is how GibbsCAM works with y-axis turning, including prime, combination of tools, and it's just done in one sweep. And then, last but not least, let me go and post that out. Okay, this is my post. This is my naming of it and stuff. Okay, and now I go say process. And here is the code. And this is the code that actually went directly into the machine, going all the way through all the operations. And I'm just sweeping, going down to the sweeping. So this is my sweeping code that actually we saw our last operation. So that's the code that went straight into the machine. We plugged in the tools, plugged in the material, and we're running the part. Okay, so this was my demonstration. I hope you enjoyed it and you learned a little bit about it, about GibbsCAM and what we can do with the combination of those wonderful tools from Sandvik, those combo tools, Prime A, Prime B, and the D-style and the other combo tool. You know the definition better than I do. But no, I love those tools, and this is what we can do, and we are so proud of it to have the coordination and cooperation together with Sandvik and GibbsCAM.
Yeah.
Well, back to you, Keith.
Andy, thank you for a wonderful demonstration of the software. There's some things as a long-time CAM user that I've noticed inside, excuse me, of GibbsCAM that help workflow. Workflow moves pretty quickly. When you have your intermediate tools designed for these blocks, when you have those properly designed, you're going to create code for y-axis prime exactly the same way you create it for x-axis prime.
Exactly.
Or traditional prime. The software is smart enough to know how and where to flip that tool. So for those of us on the programming end and those of us who are trying to push applications through, you don't have to learn two different sorts of things.
Yeah.
Also, click and drag capabilities inside of Gibbs.
Yes.
Very, very efficient.
Yes.
Also, elimination of undercuts without adding branch geometry. Very efficient way to do things inside of GibbsCAM. So there are many, many powerful ways inside of Gibbs. to take the most advantage of the tools and this technology. And let's not make any mistake about it. These tools are challenging to run, but when they're in and when they're programmed properly and when they are put in place, they can be incredibly efficient. I would argue more efficient than most anything else that we see on the market right now, as long as we quantify that we're staying within the capabilities and the range of a 1/2 inch IC insert.
Yeah.
So, okay. I understand if someone's running a 25 millimeter round, we're not going to come close to it with a 12 or even the Prime B. So we're just going to put that on the table. But where the application is applicable, the combination of GibbsCAM and the ease of use combined with this technology leads us to a really user-friendly experience to take advantage of, if we're being honest, technology that is pushing the machine tool builders to improve their equipment.
I do agree.
Okay,
Yep.
so that's pretty cool to be pushing them as a team. Your programming software, our tools. We come together here, and we're going to run this. We're going to run this demo, and again, the code straight out.
I can't wait for it.
The code straight out of the machine, right in, plug, trust it. So, thank you for your presentation.
My
We're going to
pleasure.
watch this demo. The demo is about 4 minutes or so long.
Are we good?
Yeah, you can go ahead and shut that.
Okay.
The demo is about 4 minutes long. So we're going to take a look here. Well, Andy and I will talk over the top of the demo for the things that we see and maybe some things we want to point out. I do want to quantify a couple of things and qualify a couple of things for our audience today. We did not optimize this program for high production run.
No.
Could we have trimmed more time out of this? Yes, we could have.
Definitely.
It's possible. You're going to see some lengthy moves in some places that wouldn't be there if we had gone in and say like a turnkey process or where we'd worked hand in hand with MTM. But keeping that in mind, what we do want to showcase, Andy, is the flexibility of these tools.
Yeah.
Now, I also want to point out before we get into the video, with this particular machine, tool changing from one tool to a brand new tool in the spindle and going through that entire macro, that entire motion of what it takes to do, chip to chip time on this particular machine was 20 seconds. Okay, we timed that. We are going to have some moves when we index these tools, right? When we take them and we send them back to home and we index them with our A spindle, or maybe we go here and we take the round, or we take the D. These are going to look like very painful moves, but they're actually 50% faster than what.
Even then, but still,
yes.
It's unbelievable.
Even with no optimization,
Correct.
The tool change time is still 50% faster of what we would have realized. So, with that said, demo. What are the highlights, or what are the points of the demo? We have no tail stock. We're roughing with Prime B Generation 2, 4140 material. Pretty standard cut data, but I want the audience to take note of a few things. The sound of the cut, okay, or better yet, the lack of sound in the cut. And for those of you in the digital audience, it's truly, you owe it to yourself to get in front of one of these tools at some point. There's really no comparison to what you don't hear at the machine.
Oh, absolutely. This is music, actually.
Yes. So we want to point out a couple of really interesting things. No tailstock. We have a good set of gripper jaws, but we're only holding on to 1 inch worth of material. We have 4-inch diameter sticking out 5 inches. And we even have an extension on our Y-axis tools because we needed that to clear the chuck. So with all those things in mind, the demonstration that Andy just gave you, we're going to go to the machine. Andy, do you want to close the door completely on the machine there for us?
Okay. Yes.
Go in there.
Yep.
Close it all the way. Yep.
Okay. All right. Be good.
All right. And now into the machine we go.
Okay.
So we can see the orientation of this tool up here.
Yep.
How it comes down in the Y-axis versus the traditional X. Now going to full screen, we get a chance to take a real good look inside of, we get a chance to take a real good look inside of the machine here and take a look at this prime bee doing its roughing. Andy, that really is, we're taking, as you pointed out, a pretty aggressive cut, no tailstock support.
Absolutely.
But, I mean, it still sounds really, really good out there on the end of it.
Oh, absolutely, not scary at all. And I know, okay, that insert can take actually quite a bit more feed rate. We could increase that to make it even better.
Yeah, we could definitely increase the cut that on that on that particular pass. Now here's the traditional tool change we were talking about. We're abandoning that B tool and we're going to take a look at our CoroPlex YT. Okay. This is the 20-second chip-to-chip time that I was talking about.
Okay, this is the volume turn cut. Hogging out that big area back there. It's beautiful chip control. It's fantastic. There is no screaming or whining of the tool or the machine actually also as well. It just takes it like butter. It's fantastic to hear and see. I'm telling you, it has to stand in front of it.
Yeah. Yeah, watching a video of one of these tools and seeing it in person really is, like most things in what we do, it's two different worlds, but the security in the process and the stability of these tools is truly mind-boggling when you stand next to the machine. And then you touched on something else, Andy, that sometimes the market feels that they can't use a round insert because they don't know how to get chip control. Well, with VoluTurn and the software and the macros that you have in GibbsCAM, it's really no issue.
No, you saw it right there. Okay, the chip control is fantastic, and actually, when there's a pull coming from the top, it actually pushes the chips down there right in the chip bank.
Yes.
Yep. Okay, so now cleaning up a little bit that area where the round insert actually left some stock. And remember what I said, actually material only. GibbsCAM was just basically cutting there where it sees materials being left.
Now, we want to make sure that they know when the sweep cut is coming. So
yes.
Everyone that's watching, prepare yourself for the best cut of the evening. After this undercut, we're going to see the sweeping cut, and then after we watch that, we'll have a little bit more discussion about what we saw.
Okay,
but here it comes.
Here it comes. Okay, look at that. Watch out. Sweeping around, sweeping down on the floor of that white groove, changing the angle a little bit, coming up that shoulder, sweeping around all the way again, going down that slope, OD, and now we sweep again on the bottom of that white groove, and then we go home and finish the cut. Isn't that incredible?
So I believe that brings us to the Q&A. Should we have anything in the chat there that we need to address?
Hello, gentlemen. Two questions for you, Keith. What machines currently support Y-axis turning? Kind of in addition to that, what controls support sweeping?
I know of just a handful of machines that currently are capable of doing it. But I only know of that handful because those are the machines that I am personally involved with at a physical level. I am going to direct you to say if you have a need for this or if you think that you want to engage this technology, the very first stop is going to be your machine tool manufacturer. Touch base with them, because even within the machine tool families, not every machine tool and control is created equally.
Right.
Some parts of the family may or may not, and it could come down to the controls. And if I'm being quite simply completely transparent and honest, I don't have that list of machines that are capable and not capable. I only know what machines we have that are and are not. So If we take that into consideration, start with your machine tool manufacturer, and if they quantify that you can engage the technology, reach out to your Sandvik Coromant personnel that are local to you. They will get in touch with the proper people. If you're needing ways to program this, reach out to your GibbsCAM people. But it all starts with the homework at the machine tool manufacturer to see if what you already have is truly capable of using the system.
Okay.
All right, Mr. Andy, we have a question for you.
Okay.
Can the vectors be changed manually if needed?
Oh, absolutely. That's exactly what you do as the programmer. You change them manually. They are not set by the system. The vectors are programmed by the user, actually, or set by the user. It's just a piece of geometry that you click on a point and you give it the angle. Is it 60 degrees, 40, 30, 90 degrees, 0 degrees, depending really how you want to rotate your tool around that contouring of the part. Yes, it's a user input fully. Okay.
Perfect. And then kind of a joint question for both of you gentlemen, kind of one thing that we struggled with getting this demo set up, but how do you offset, or excuse me, how do you use a offset in the machine for the sweeping turning, or how is that programmed?
Again, and I know this seems very evasive, but it really depends upon the machine. Some machines have different capabilities than others. Now, I will answer the question with what we had to do here to get this to run. On our particular machine, we had to give each position its own offset, which means we had to give it its own tool number. That's why we saw a little bit of the lagging on the spindle where we had to, kind of move the spindle back to 0 and then readjust. But our machine does not have tooltip compensation.
Correct.
We don't even have an offset for such thing, which is where the power of GibbsCAM comes in, because GibbsCAM took the quadrant in which the point of the tool was at with no offset, did all of the math in the background, and then created the proper geometry to make these straight lines happen with rotation. So
exactly.
It's really, on our machine, they were just physical different tool numbers with different offsets. Other machines could be different.
Yes.
Will be
Depends
different.
really much on the control.
Right.
Absolutely.
So it's that's how we did it. So hopefully that answers some form of the question.
Yeah.
Yes, it does. Thank you very much. I think that's all we have from the Q&A. So thank you for your time, gentlemen.
Yeah, thanks, Mark, for being the moderator.
Well, thank you. Yes.
Yeah, Andy, any final thoughts before we sign off here?
Like I said earlier already, I love the cooperation that we did together to make this powerful demonstration here. It was a pleasure to work with the tools and work with Coromant. And again, like I said earlier, a little bit, okay, like we are now one family. Right. And of course, that makes it even nicer and easier, and just the camaraderie as well. Okay, so it's a fantastic combination of things with our knowledge in GibbsCAM, your knowledge on the tooling and stuff, and making it just a beautiful, successful presentation. And time to work together.
No, thank you. It was a pleasure to have you here. For those of you out in the audience, if you do have further questions, feel free to add them to the chat. We can try to monitor them and get back to you. But a final thought from me, Andy, I echo everything you said. The collaboration has been great. We have a powerful demo. We were able to show some folks some things that, piquing interest in pushing technology and helping with cycle time reduction. And that's really the name of the game. So I would urge those of you who have joined the webinar, if you have any thought at all, any inkling, or any pain point that you want to reduce your cycle time, your roughing cycle time, reach out to your local Sandvik Coromant representative. They can talk to you about prime turning. They can talk to you about the CoreTurn 107. They can talk to you about all these things that we mentioned today and more, and go along the line of reducing your roughing cycle times and increasing your profit and your throughput. So don't hesitate to reach out. If you're having programming needs, find your local GibbsCAM reseller, reach out to them. They will support you. I have seen it firsthand. It will be a good experience for you. But last and not least, we want to thank each and every one on the other side of this camera for attending the webinar.
Thank you.
Thank you all so much for making this a
Thank you.
success for us, and we'll do our best to answer the questions. So until next time, Andy, we'll see you later.
Thank you. Bye-bye.